How to create a PractiCAD fan-powered box. In this tutorial, we're going to design a fan-powered box using PractiCAD fittings. We're going to follow this Titus submittal sheet, DTQS fan-powered terminal. You can see it's a round inlet, a rectangular outlet. We've got all the dimensions and parameters we need here. So what we're going to do now is we're going to go into PractiCAD. We're going to go into our library icon right here. And we're going to go into our ductwork libraries and pull out a VAV box is what we're going to use for this. So we're going to go into auxiliary items, rectangular, other, and we're going to choose the SD VAV box round with straight. This has the round inlet we need. It's also got a rectangular outlet which can be offset. It's got a control box on it, so it's going to work well for what we're trying to do. I'm going to open up our screen a little bit. And now what we're going to do is come up to all catalogs. You're going to hit the green checkbox and create a new catalog. And we'll just use right here, we'll just call this PCAD Titus fan box. And then we're going to give it a name. And we're going to name it 6-inch Titus DTQS Unit 2. And I like to put the name here so that when we create a catalog, we can get that drop-down list and I can see that each one, I know that it's a 6-inch Titus DTQS Unit 2. I'm also going to make sure that I keep everything in capital letters here just to keep it consistent with the names of all the other catalogs. Now there's a lot of parameters associated with VAV boxes. You've seen this in earlier tutorials. Fan boxes have some tricky offsets as well. So we're going to go over each parameter one at a time. First what we're going to have here is obviously the width out. We can always see what the width out is by just simply scrolling. You can see that is obviously the width out. I'm going to change my preview here to isometric. We can see that the width out is the out and the depth out is for that straight out. Then we got width on body and depth on body. So I can always see what parameter controls what. So we're going to go to our submittal sheet here. We're going to see what the width out is. And the width out here, we've got it right underneath parameter F. You can see the width out seems to be that it's going to be 14. Remember, we're doing a unit size 2, 6-inch inlet. So what we're going to do here is we're going to say F is 14, and then we're going to look at what the depth out is. And that's going to be the parameter J. Looks like it's going to be 11 right here. So we've got J, which marks the depth out, so the opening. So 14 by 11. So we're going to come in here and type in 14, hit enter, 11. Then we're going to go to the width on body, depth on body, go back to the submittal sheet. Here we can see that the width is going to be, looks like 36 and an eighth, represented by the W. And then we got H for the depth, which is going to be 17 and an eighth. So 36 and an eighth and 17 and an eighth. So we're going to come in here and say width on body is 36.125. And the depth on body is 17.125. Once again, notice that I have AutoCAD format set to decimal. And I have the precision set out to 3 decimal places. This way I can put in those eighth of an inch. If I've got the format set to just 0.0 or the precision to 0.0, I'm not going to be able to put in the eighth of an inch we need. So before you start designing fan boxes or VAVs or equipment that requires eighth of an inch, I'd recommend changing the format precision in AutoCAD format units. And there are tutorials on that. So next thing we're going to do here is we got to choose the tab diameter and length. The tab diameter we know for this one we're going to use is 6. And once again, we're going to use the nominal size for this particular fan box. Sometimes the diameters can be smaller. We want it to report as 6 inch, so we're going to use it as 6 inch. We also want duct that attaches to 6 inches to be 6 inches, so we usually go by the nominal size. The length we're going to get off the sheet, it looks like length will be L. That's going to be 40 and 7/8 long. So we're going to come in here and say length will be 40.875. Straight out, we can put whatever we need. It could be 0. I'm actually just going to put it at 0.1. That's the distance. You can see the length of the straight out. I'm just going to put it at 0.1. It's going to put a tad little edge, but you could have it longer or at 0 if you need to. Now what we have is the offset. And this is the offset, as you can see as I move it. This is how far the offset is for the back straight. I'm going to set it to 0. Now you can see that 0 is obviously from this side. So as I type in 2 inches, that means that the side of this wall right here is 2 inches from the back of the box. So if we come into our PDF, we can see here that it's given us a parameter G. And that parameter is 3.5. So we can actually just put that parameter right there. So we're going to say that the offset here is going to be 3.5. Then we're going to have an inset. That is how far up or down it goes. You can see if I type in 0 for the inset, it's obviously flat on the bottom. So our inset parameter is working off the bottom. So let's go to our PDF sheet, and you can see here that we're probably going to have to do a little math to calculate this. There is a parameter, but the parameter here is K, and K is going off of a different side. We're actually going off the bottom of the fitting, and you can see that it is also centered. So what we're going to do here is, we're just going to write a little formula, and I've got it up here. You can see that the inset is actually going to be the depth of the body of the fitting minus the depth out of the fitting, which actually tells us how big the space is that's left over. And we're going to divide that by 2, and that's going to put this fitting in the dead center. So what we're going to do is just come up to our calculator and say depth on body is 17.125, getting that number from right here. And then we're going to say minus the depth out, and the depth out is 11. And then we're going to divide that by 2. That's going to be 3.0625. And that's what our inset's going to be, 3.0625. And we're going to hit enter. Notice that because it went out to 4 decimal places and my precision is only 0.000, 3 decimal places, AutoCAD rounded this to 6.3. So if you wanted 4 decimal places, once again, change it in your format precision. Now we've got tap length. Tap length should be already listed. We can see right up here that it says 3 3/8, and that is the distance of the tap. Seems to be consistent everywhere. So we're going to go back here and say that the tap length would be 3.375 for 3 3/8. And tap offset. Now, tap offset is going to be the trickiest one of all. The fan box actually has the tap basically on this side. And we're going to zoom in a little bit. We're actually going to put this in the left view. It's always good to change your view. You could see here if we take the tap offset and we set it at 0, that it's actually flat against the wall. So if we actually take the entire width of the body and subtract the diameter, that number is going to be the space we have left. But the PDF sheet is actually, it's giving us a parameter here for A, and that's the distance from the other side of our fan box to the center. So we do have to write a little formula here. And you'll want to do this one time, and then every other fan box of this type will be easier. And depending on what information is given to you by the manufacturer is going to affect what this formula is. In this tutorial here, you can see that we've got A, which is listed, which is the distance from the edge to halfway through the diameter. So really it's, we got A is 6 inches right here. That's the one we're using. And you know that the diameter is 3. So you know that there's 3 inches between the center of this diameter and the end of this tap, which means that the remaining gap here would be 3 inches. So if you put this together and you can pause to just go over this, you can see that the tap offset parameter here is going to be this following formula. It's going to be width body, the whole width of the body, minus the tap diameter, and then you're going to subtract the difference between the parameter A and half the diameter. And just take a minute to pause this and read over that to make sure you understand how I'm getting that. It might be different on a different submittal. They might go off the other side, but our system's actually going off of the right side. So what we're going to do is come back here and we're going to calculate that tap inset using that formula. We're going to go to our notes, open up our calculator, and we're going to say, okay, the width on the body is 36.125. And we're going to subtract the tap diameter, which is 6. And then that is a number. Now from that, we need to take the parameter A, which is listed as 6 on our PDF submittal. That's right here. A is listed as 6, and that's the distance marked right up here. So we're going to take A and subtract half the diameter. So A minus half the diameter, which is 6, is going to be 6 minus 3. And that is what we need to subtract off this number, according to our formula here that we wrote with unbodied. So we're going to put in 27.125, and that is the correct value, 27.125. And that's where this should be in terms of left and right. Now we've got the tap inset, which is going to be up and down. And once again, I'm going to set this to 0. And here on our submittal sheet, it's actually just telling us this parameter for B. But that's also going after the center line as well. And once again, our taps are working off the edge. So what I've got here is I've also got a formula for the tap inset. And it's just going to be the depth of the body minus the diameter divided by 2. That's usually the same for almost all fan boxes and VAVs. So what we're going to do here is we're going to say, okay, depth of the body is 17 and 1/8. We're going to subtract the diameter, which is going to be 6. We're going to divide it by 2. And 5.5625 is what we want here. 5.5625 is actually the proper parameter. And this puts a dead center up top and left to right. So now our offset parameters are correct. After this, it's going to get a little easier. The tap offset is the only real tricky one. It's good to write out a formula like that. And then once you've designed one, it gets pretty easy after that. Now we need to do length 1. Length 1 is for the control box. The control box has a length. You can see as I extend it. A width. 1 is for control box 1 is the width. And the depth. And we're going to go into our submittal sheet and see what we have here. We have the length is marked here as 20. We've got the width. Well, depth is actually 12. It's marked right here. And we're also going to get the parameter for width. And the width looks like it's marked here at 6 1/4. So what we're going to do is we're going to come back in and we're going to put in these values. Length we know is 20. Width was 6 1/4. And our depth, we're going to double check. Looks like the depth's 12. So we're going to change that depth to 12. And offset 1. Now, what we're going to do here is move this into front view. Take a look at the offset. The offset's obviously moving. It's working off of 0. And 0 is actually the front. And what we're going to do here is we're going to change the parameter for offset so that it's correct. And it should be marked on our submittal sheet. It looks like what we've got is a parameter here, N. And that's telling us the distance from the end to the front. And it looks like it's 2 7/8. So that's actually the number we'd want to use right here. 2 875 7/8. And next we're going to have the inset, which is going to be how up and down. And actually in the submittal sheet, if you look at it, it's actually centered. Inset is centered, right in the dead center of the fitting. So the property or the formula here for inset 1 is going to be, once again, it's going to be the depth of the whole fitting minus the depth body minus the depth of the control, which is depth 1, and you're going to divide it by 2. And that's going to be the distance to make this center. And what I'm going to do, but notice here it's marked as a minus value. And the reason why is you could see here that this box is smaller than the fan itself. So inset being 0 is at the top. And if I move it negative, it moves down. So that's why I've got a minus value here. So once again, take a minute to look at the formula for inset 1 here. I'm just going to take the depth of the body minus depth 1 divided by 2. So we'll go up to our calculator, and once again, we're going to say depth body, which is 17 1/8, minus depth 1, which we know is 12. We're going to divide that by 2, and 2.5625. But we need to do that negative. If we do it positive, it's actually going to go up. You can see here, inset, we actually want a negative 2.5625. And that right there puts the tap perfectly centered. So I've got this little formula sheet that we've got here to calculate. After that, it gets pretty easy. We don't have a second control box. So length 2, width 2, depth 2, offset 2, and inset 2 are going to be set at 0. We've got the hole width, depth, offset, and inset. These are once again fabrication parameters for the hole. Practicam will cut it if you're downloading these. Most contractors are not, so most of the time they're set at 0. We're going to choose the control side. In the picture, they've got it on the far side. Here we've got it on the near side. So you can always, always change it to what side you want. You can do that on the fly. But far is going to be on the right. Near, I apologize, is going to be on the right side based on airflow. And far is going to be on the left. It's all about the in connection. So we've switched it to far. And now we're going to choose the material, gauge, connector in, connector out. This is going to differ, it's going to differ between contractor. Airflow we're going to set at 0, but we could put in a CFM if we'd like. We can give it a model number here. Once again, choose the fabrication level, and then if we do need liner on the outside, it could be done liner insulation. Once we've designed this one, what we're going to do is just copy it by highlighting the one we've created, then typing in 8-inch Titus DTQS unit size 2, and then what we're going to do is make the changes. And obviously between fan boxes very few parameters change, so a lot of these will stay the same. Once we've designed our fan boxes, we're going to hit save, and then we're going to drag this catalog off into our bin. And then I'm going to exit out of the library by using the close key right here. And now we can go into our bin and we're going to have a catalog of Titus fan boxes. Obviously the 8-inch one we need to adjust, but here we have our 6-inch fan box. We can hit place, and now it's ready to go, and we can just put it on the drawing. And that concludes the tutorial on building a fan box.